Hello everyone and welcome to today's Chemistry Daily Booster. This is number 19 in our series for paper 2 and it is on the advanced information for both foundation chemistry and higher tier chemistry. What we're going to do then is start looking at the organic chemistry section. So to start off, let's know the definition for a hydrocarbon. When we talk about hydrocarbons, these are compounds made from hydrogen and carbon only. Make sure you include the word only if they ask you to define a hydrocarbon. What we're going to do then is we're going to have a look at a series of different organic molecules. The first one we're going to look at is an example of a hydrocarbon. We're going to look at this family called alkanes. Now, alkanes form what we refer to as an homologous series because they've got certain features in common. They've got the same general formula and they are all saturated. And something that's saturated only has single bonds between the atoms. No double bonds, only single bonds. As far as the information we need to know about alkanes, first thing, we need to know how to name them. So the first part of the name comes from how many carbon atoms there are. And this little table over here just gives us what we need to remember. So 1 carbon, meth, 2 F, 3 pro, 4 bute, 5 pent, 6 hex. Learn those prefixes, the starting bits of the words. Because we're talking about an alkane, then the ending will always be ANE. So if, for example, we had a substance that had 2 carbon atoms and we needed to know its name, then it would be F, because it's got 2 carbons, and because we've only got single bonds, ane, so it's ethane. We also need to remember the general formula, CnH2n plus 2. So if they were to ask us what would the formula be for an alkane with 6 carbons, then all we do is C6, then H, 2 times 6 is 12, plus 2, 14. The only other bit they could ask you to do is to draw the displayed formula. Now, this is quite straightforward because all we do is we start off with the carbon backbone. I'm not going to do a large molecule because I haven't got a small space here. So what we're actually going to do, we'll do ethane for the sake of it. So we're going to do ethane, which is C2. Let's work it out. 2 times 2 is 4, plus 2 is 6. So start off by putting your carbons in a little line. Only single bonds, remember, so a single bond joins however many carbons you've got. Carbon has 4 bonds it can form. So make sure there are then 4 lines coming off of each carbon in total. We've got 1 between 2 carbons, so 2, 3, 4, 2, 3, 4. Then stick a hydrogen on the end. So on the end of any open bond, just put a hydrogen, and that is your alkane done. When we consider the reactions of the alkanes then, there are 2 combustion reactions we need to know about, complete and incomplete. Complete combustion is where we're going to just form carbon dioxide and water. We are going to completely oxidize our hydrocarbon. Incomplete combustion will happen when we don't have sufficient oxygen present to do that, and as a result what we form is carbon, carbon monoxide and water. Family number 2 of our chemicals then, the alkenes. These are still hydrocarbons made of hydrogen and carbon only. They are a homologous series, but the key feature here, they are unsaturated. That means they contain at least 1 double bond. The general formula for our alkenes is CnH2n. So again, the naming is going to be incredibly similar to our alkanes. First part of the name comes from a number of carbons. Let's do 3 this time. So if we've got 3 carbons, that starts as prop, and then because it's an alkene, it ends in ene. So we have propene. If we wanted to work out, obviously, the formula, propene has 3 carbons. So C3 and then H, 2 times 3, is 6. Only other thing we could be asked to do is to draw the displayed formula. So in that case, we still start with our carbons in a line. Remember, we need a double bond, so it doesn't really matter where you put it, just stick a double bond between 2 carbons. Then we've got to make sure every carbon has 4 lines coming from it. So we've got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Put a hydrogen on the end of any of those lines, and we're done. So it doesn't matter where the double bond goes as long as it's between 2 carbons, and it doesn't matter which position you put the hydrogens in. So if you wanted to put the middle one going up instead of down, it doesn't make any difference as long as there are only 4 lines going from each carbon and only 1 line to a hydrogen. What we find in terms of the reactions of our alkenes, they undergo combustion, same products as the alkanes, either complete or incomplete. And if they ask you what is the functional group of the alkenes, that's what we're going to write. 2 carbons joined by a double bond. So you don't have to use any fancy name. If they say what is the functional group of the alkenes, all you're going to do is that. If they ask you what a functional group is, it's quite simply atoms or groups of atoms or types of bond that are responsible for these characteristic reactions of our substance. So the defining feature of our alkenes is that double bond between the 2 carbons, hence it's the functional group. With the alkenes, one of the key reactions that they can carry out because of the presence of that double bond is an addition reaction. So this is just where we join several of them together, or we join our alkene with other molecules with no other products. We're literally just kind of joining things together to make a larger molecule. And we're going to look at the example of addition polymers at a later stage. An old favourite, how do we test 2 unknown substances to identify which is the alkane and which is the alkene? Easy. All we're going to do is add bromine water. So all you do is you say you add bromine water to the 2 solutions, give it a shake, and then we look for the colour change. If it goes from orange-brown to colourless, we have an alkene. If it doesn't and stays the orange-brown colour, it was an alkane. The reason for that is with an alkene, the bromine is just going to add to the ethene molecule. We're going to do an addition reaction here. So you can see if we look at the balanced equation, it's potentially a bit easier. So we've got C2H4, that's got a double bond, remember, between our 2 carbons there. Then what we're going to have is our bromine, and then what we're going to form is our 2 carbons. We're still going to have our 4 hydrogens, but we're also going to have 2 bromines attached as well. And that is what we mean by an addition reaction. We've just added the bromines to the ethene in this case. Third family, the alcohols. So alcohols then have the functional group OH, which we can call hydroxyl. All of their names end in ol, and their general formula CnH2n plus 1 OH. So we stick the functional group at the end there. If we want to obviously work out the displayed formula, let's do 2 carbons in this case. So let's do C2 first of all, then our hydrogens, 2 times 2 is 4, plus 1 is 5 OH. So there's our formula. Start off with the carbons as the backbone in the middle. Then we're going to have our bonds coming from carbon equating 4. We've got 5 hydrogens that are going to join on. So stick on 5 hydrogens, 3, 4, 5. And then we've got to have the hydroxyl. So oxygen and hydrogen. Please make sure that you do it that way around. The oxygen, then the hydrogen. Because oxygen can form 2 bonds, hydrogen only 1. So don't put those the other way around or it will be wrong. If we look at the alcohols burning then, so combustion reactions of the alcohols, then complete combustion, carbon dioxide and water. Incomplete combustion, we're going to make our water vapour, carbon monoxide and carbon. we can also oxidize an alcohol to form a carboxylic acid, which is our final group, the carboxylic acids. Their functional group, COOH. This is our carboxyl group. All their names end in anoic acid, and their general formula, CnH2n+1 COOH. Just remember though that one of the carbons is in the functional group of the COOH, so don't add in an extra carbon by accident. So I've given you the example of pentanoic acid, so pent means 5, so there are 5 carbons, and if we look, we've got C4 because the 5th carbon is there in our functional group. So just go careful with that to make sure that you're not adding in a random extra carbon. In terms of what that functional group looks like then, we're going to have a double bond to one oxygen, a single bond to another that then leads to the hydrogen. So that just gets stuck onto the end of whatever molecule you've got, and obviously you can just join your carbons in their usual little backbone format, add your hydrogens, and you're done. In terms of the reactions of our carboxylic acids, then as we've said, they will form when alcohols are going to react with oxidizing agents, such as potassium manganate. So we start off with our alcohol, ethanol here, and we're going to make ethanoic acid, the carboxylic acid. And the way we do that is by reacting with potassium manganate and some dilute sulfuric acid. What happens is those manganate ions, which start off as purple, as we can see in this tube on the left, get reduced to form manganese ions, which are pink in colour. That's then also at the same time going to oxidize the ethanol to the ethanoic acid. One point that's worth remembering here is our carboxylic acids are weak acids. That means their reactions are going to be the same as acid reactions. So they react with metals to produce a salt and hydrogen. They react with alkalis or bases to produce a salt and water. They'll react with carbonates to produce a salt, water and carbon dioxide. So just remember they have the same reactions as other acids. When we're looking at the salts though, they all end in this phrase O8. So if we look at the example, ethanoic acid and sodium carbonate, so what we're going to form is a salt, water and carbon dioxide. So there's our water and our carbon dioxide. And then our salt, we're still going to take the name of the metal first of all, sodium. There's our sodium. Then we look at the acid, and we've got ethanoic acid, but remember we need to change it to the ending O8. So ethanoate is the name of our salt. If there are any bits in here that you'd like to go through in more detail, then you can use the C6 playlist on the main channel where we go through each one of those in a lot more detail and a lot more gently. Of course, you can also use your revision guide, and I do strongly recommend looking at past exam questions on the organic chemistry part. And then, of course, don't forget to join us once more tomorrow for our next Daily Booster.